audio and until now algebra part हुआ था टॉपिक लास्ट टॉपिक पॉजिटिव डेफिनेट व्हाट इज नेगेटिव डेफिनेट व्हाट इज ये टॉपिक्स इंपॉर्टेंट है जब हम बात करेंगे ऑप्टिमाइज तो जस्ट यू हैव टू डोंट फेस एनी प्रॉब्लम just for the recall purpose because the optimization problem one variable one variable you have some what was it x what was the condition find the critical points are one okay then you check for double dash negative positive we have seen graphically the last class we have seen how why this thing, why how this works or we what does that graphically why the same criteria will hold for the So okay, तो इन्वर्टिबल वेरिएबल केस इस टाइप का कोई फंक्शन गिवन रहता है. So not going into too much details about gradient part of a vector calculus codes, but you can tell you something. Just like in the first variable case, we have the first derivatives, yeah, d by dx for the first derivative. Here there is a function with two variables, so we will have two first order derivative, and we store it in this form the triangle. Store these f, this is partial derivative. What's partial derivative is? We store this as, so this is called gradient. This is called del or blah. Call it del or gradient. Okay. You store this. What does it do? Again, I'm telling you, I'm not going into too much detail. Just you have to remember one thing. It tells you the direction. The vector, right? So the vector always gives a direction. The vectors are always like this. They're pointing somewhere. Now I'm going to tell where it is pointing. So this always tells the direction of the best. So think it like this. You are, suppose that you are on a mountain. You are on a point. Okay? So it will tell you the gradient will on your foot. Because fxy equals to z, it will be a 3D mountain or some curve. Okay. And this clearly this gradient is something of two variables. It's an R2, right? It tells you a direction. In what direction it will point out? It will point at the steepest possible direction. यहाँ पे सबसे ज़्यादा होगी कि वहाँ पे पॉइंट आउट करेगा. Okay. The opposite of it will be steepest descent. So just put negative of the gradient, you will get a descent. This is not, but it's okay. Okay. So the direction of the steepest ascent you have to remember what the gradient is. Suppose you have a function like this. Suppose you have a variable function like sine to f by f by I. Treat other variables as a constant and just derivative with respect to x. Then do I x cos in vector. The vector. Just remember, gradient vector will be x sine I. Just remember this thing. This you can work it out on a 3D Desmos website. Just put this sine y there. Get a mountain shape object, and on that mountain, if any point on that, when you see below your foot, the gradient. will tell you the direction in which the mountain is the steepest if you are going up. And the length of this vector, this gradient, tells you the how steep ascent. Okay. The condition is that suppose that you are already on the top of a mountain. There will be no ascent. So just like a single variable calculus, like in a single variable, what will happen at this point? So becomes similarly here for the two variable case, this gradient will become zero. So there will be no ascent. You're not going anywhere. Okay. Just have to remember this. Now I'm going to tell you. Suppose that by solving these two, df by put this df and this df y equals to 0. Again, you will find a dimension point. That will be our critical point. We'll find critical point like everything is same. That is all same. You find this critical points. Yes, then put them in it. Will be more not a good way to just you can find the critical point, but it will not tell you it is a local minima or local max. Again, just like in the single variable case, here we have a condition, the second derivative condition. Okay. Now, the idea of positive definite matrix and you will use defined use definite. I remember one day someone asked me the criteria for there are how many criteria for finding if a symmetric matrix is positive. So there was one thing that was semester criteria. That's what I am going to find if you have like you have done with this. ये हो गया. You found the critical points. Now you have to check that if it is a point of maxima or if it's the point of. So we will a matrix Bayesian matrix. Okay. It contains second. Okay. Uh, for the two cross two for a two for a fx y for a two variable case, the Hessian matrix H look like second derivative, second partial derivative. Okay. Then second partial derivative with respect to x and then with respect to y. Here it will be the same. These both are equal. It has to be symmetric. Cannot talk about definedness of a matrix if it is f by. Okay. So the second derivative tells you that if this matrix is positive, definite. That means condition was all eigenvalues are positive. That was the first condition. Second condition was that the first element, that's a standard way of writing the second derivatives. Write it like r is the r s. So also they are equal. This is t. So the first condition is that. Second condition for the positive definite. First condition is that if all the eigenvalues are positive. Second condition is that this r is positive. The determinant of this 2 cross 2 matrix is positive. What will is rt minus s? Then we will see positive. If this happens, these two conditions satisfy, say that our point at which this Asian matrix was calculated, matrix is calculated out on critical points. They are not unknown variables. Not unknown. They will check this derivatives at the critical points. So when you will do this, if this happened, it is a positive definite matrix. Then is the minimum. That is the point of a local minimum. Most of the time, we will be using only this condition. Most of the time. Okay. You remember from the previous class when we have a positive definite matrix, the quadratic form of their it will be a shape of a convex shape. Now from there you can see why it is a local minima, the point of local. Okay. For the second, this like if it is negative definite, for which the first condition is that if all eigenvalues, if second condition is that, see carefully, for the negative definite matrix always start with a negative sign, that r must be negative, and then rt minus s square. There is a pattern in negative then positive. You have more than one variable, the this matrix will grow to cross 3. Then last minor or the third minor of 3 will have to be negative, negative positive. Okay, alternate sign. Then we will say that it is a point of we will use only these two conditions. These two conditions are known as the criteria. Already discussed this. Okay. So we will use this when we have critical points. After that, let's see. Let's see. this question. Fxy is equals to x square y y square. So we are given just this two variable equation. It lives in a 3D space. May look like a mountain or something, and we have to find there is a minima point or a local minima point. We have to just first condition. First step was that. What was the first step? First step was that you have to find the critical points. So f by del x partial derivative of this will y, put this equals to 0 and solve the equation, and then do del f by y by, so solve it. Y equals 1, divide by 2, and then for x y equals y equals put them the equation, and you will get y equals to any situation. It is not as easy right now. Any situation, x to 2 by 3 or 0 can be two roots. इसमें क्या है कि हर टाइप का कॉम्बिनेशन लेना होगा. Will just don't ignore these exercise. So we have a critical point. This is our critical point. Now we have to find r. R, what was r? Was del 2 by del x by 3. We are sure that at this point, at this 2 comma 3 and minus 1 by 3 and by 3, you will surely have the gradient 0. That means either we are at the minima, or either we are, well, now I'm looking at is this local minimum, local max. So what will be the second derivative of the first? No point of values. As s x del y del x, worry about. So del f by del y will be 1. Del y del x, then t. Again, there is some values put this critical. I don't have any value, it's a constant. Now rt minus s, that is two, r is, that is also that indicates that is a point of local, right? Positive definite matrix. Positive definite matrix, which point? By 3. Now, any equations, economics or mathematics, there is not direct optimization problems. There are always some constraints on which we have to check our stability of the curves. Now I'm going to talk about constrained optimization. So how does it look like? How does it suppose that fxy is given like this, and it is, we have to maximize it, constraint square plus I square equals, so you can look it like this. Suppose that we have and this is representing circle. I'm what is the problem? So this is circle on this flat surface. Then we have a curve. I don't know how it will look, but the 3D mountain नीचे कर्व है. So for a 3 cross 3 matrix, what is the criteria? You have to check for 3. Maybe you can check eigenvalues. All the eigenvalues negative definite matrix. You have to go from the minor product. Then you have to check for the first minor, then positive, and the alternate side is not following any pattern, negative negative, then definite cannot semi. Okay, see, so this is our problem. अभी यहाँ पे क्या है कि इस ये क्या करेगा, इस माउंटेन को ऊपर से बाउंड करेगा, बाउंड अवर माउंटेन. It's looking so easy. I mean, not like it's a simple slope, simple mountain, or you can say, oh, okay, maybe can we look like level curve? Told you about the level curve. Is the problem clear? हाँ problem है हमें. There will be so many level curves, but level curve is the mountain. You fixed one some height. height. This is the level curve contour of this curve, particular contour. So just project, just take a bird eye view from here. Try to here. You'll see that curve will look like this. This is our set or content in which we recognize these values. The contours for this case will look like this. So there will be many uh, contour lines on it. This that one contour here and one contour here. When you look from the above, so what I'm telling going to tell you that trying to tell you is what I'm going to tell you is that just focus on these points. They're just touching the constraint equation and the special lines. They're just touching this. Okay. I know that the local minima or maxima always be on this point. These points. I don't have to look outside this. That's the meaning. Constraint. Be on this line. Square plus y square equals. So due to our constraint, all the minima or maxima are these 4 points only. Now try to focus on one touching point where it is touching. Just touching this. Okay, so we have a point and a contour line like this. Just focusing about on this. Our constraint line goes. This is function which we have to maximize. At this point, we have to check if it is of maximum. So why contour are important? See, when you are on a contour, when you are on a mountain, and then contour means the you are not going above or down, not going up or down, just on a no time. You have some mountain like this, and there is some curve like this. So this is called contour curve. There can be many contours. When you are on this, so that you are on this point and you are just circling about on this, you're not going up or down. What will be the steepest point here? Where should you go? The steepest point will be the perpendicular. The gradient will be perpendicular. These both. Okay. That means that for the both the curves, the gradient will be perpendicular. So suppose for this red contour line, the gradient is this. The length of the gradient may change, right? The gradient will be this. For the blue line, for the blue the constraint equation, you have a gradient like the length can be different. This is the main idea. The length of the vector can be different, but they both are perpendicular. Or I can say that they both are proportional. The gradient, the gradient of level our paint is equals to some equals to our gradient of the contour, the gradient of our equation, and with some proportionality constant, we denote it like lambda is also known as multiplication. Now this is hard to tell you why matlab, vector how vector is representing only the steepest point without studying vector calculus. I hope you got the idea. We just have to do one thing. We have two equations. Okay? One is the constraint and one is our function which we have to maximize. Just look at the gradient of these. The gradient of both of the gradient should be equal to each other. The proportionality constant we have is called as with the help of this we can solve. We have here for a two variable case we have del g by del x by time f by del x by solve it. We'll get have to find x and y, but the problem is that there is only two equations. There are three variables. One is lambda. The third, get these two equations. Get by del x f by del x first, second by del x f by y. Third equation will be only whatever the constant. What will be our constraint only. Okay. Okay. So this method is known as Lagrange multiplier method to find the maximum. So, start with one question. Uh, this is our question. This is the you have to minimize this set to this constraint. Constraint can be can like this. Take it from here. Remember what was the first equation? Was del G minus theta times condition. It take one. Let us denote L, a whole function lambda multiply. Just take 2xy minus lambda times square for y square. Take minus 36 on this side and write it here, or you can just leave it on. Okay to write. Doesn't matter. Okay, so this is our L. First thing you have to do is, right, you do this, get y minus lambda x, then find del y, derivative of with respect to y, get to x minus the y. The third equation you will get directly write it from our third equation was this only. Find it from here. How? Just derivate with respect to del lambda. No need to do it this. So with respect to lambda, there will be minus time square y square, or it is not square plus. So you have three equations. One, oh, this is it. So you have three, two and three. Just we have to find the variables x plus 2. The first equation we have is 18 lambda y y minus, that will give y equals to 9 lambda x. Equation have to 8 lambda y, that will give x equals lambda y. Now we have now we can put these two in the third and then solve. Third, from the third equation we have 9x y equal, you can just replace y here. X 4 lambda x 6 x 6. Okay, now either x can be 0 minus 36 square can be, if it is 0 then we find that lambda equals plus minus. Now x cannot be 0, because if x is 0 then this happens, xy what, Uh, xy at 0 it will become 0, but that that of course it is not a, it will not be the point of, because in our condition 9x square plus 4y equals to 36 is allowing the other quadrants of also, that implies that it is for values of negative values of x and y, it can go below that. Just we work with this only. So now finally we have y equals to 9 lambda x. That implies that y square will be 81 square. That means 1 by square squaring both sides. But this implies that 36 y square equals to uh, by 4x square. Get 4y square equals to infinity in equation plus 4y equals to 36. It 36. Four. That would mean that 4y square equals y equals to by 4 square equals to 18. Plus minus. Now you have both the points x equals plus minus 2, y equals you have function. Okay. So again we have to find the minima. So if we take both the signs to be positive sign, it will not give. They are both positive, then it will positive number. But we have we can find a negative value clearly. We are taking okay. uh, symmetry have to check for the cases. Just take any number to be positive to and this cannot take both positive and both. If you take both again, xy will be times five minus 9. It's all about the Lagrange multiplier method. uh, One thing, theory, I told you that I have taken the constant side and the number this side, but that does not matter. You are familiar with the if you are clear with the idea, does not matter, of course, because what is this lambda? Lambda is just some constant. I don't know what constant, but I can take lambda this side. It will be by lambda. Then again, note it as lambda or some anything. In many books, standard books, they have taken like this problem this side and then that times the constant. The standard way find in. I will tell you or classrooms also how it is follows. But the subtle idea was that they both the gradient will be to each other. Proportionality constant can be any either side. This is how Lagrange method works. Find Lagrange multi you use it in just starting from this partial derivative Finding the critical points. Again, check. For the second problem, for the edge, look big but feel. Again, start with L. L define. L will be our main problem, that is 100 minus, then minus lambda or plus lambda, it does not matter. But what is our constraint? This side. They are clearly saying that you have to the first quadrant only. That you have to find the partial derivative for minus x. The check. Okay. First equation. Second equation will be y give you y okay, this for minus. What will be the e? Third constraint. Third del L by del lambda, and then really right constraint. The constraint is y equals to e. Yeah. Equations. The first equation, write it minus y. Now I can compare the powers. If minus x, I can I have x equal y minus. Putting this x value in the this at y minus. I have to find y from here. Y Here Py is this. T plus 1 I square minus. Now for x was points are values are 1 divided by square minus I is so the optimal solution achieved. We have some only one critical point, nothing to check here. We are saying that it is of optimal point, don't have any option for other values like low or some one point, it have to be maximum. These points are our x star and y star. You need to check other points. See. Now what they are asking? They're asking for what is the value of I star divided by x square. Them square divided by e square minus 1 divided by e squared. That's how you do functions on Lagrange multiplier. Practice more and more this topic. Very familiar with differentiation. Okay, so these are the problem for constraint, one constraint only. Now there are situations where there is not only one constraint, there are more than one. Suppose, for example, problem fxy, our function, there are more than one constraint, like one xy xy. These types of problems use LPP programming. Let's start with one problem directly. Problem here, very easy. Just have there are three constraints here. Just 22 time problem. Questions optive this constraints with me. First one is 5x plus 4y. Remember, you always have to draw a diagram. Just have to draw lines, and the first problem, the first thing you do is that raise this inequality with and find the points x or y where they are in. Put x equals to 0. Put x equals to 0, the y will be 5. When you put y equals to 0, x will be. Second question is x plus 5y equals to 50. Less than equals to 15, but I'm again that just for equality. X is equals to 0, you will get when you y equals to third, 4 box. So y will be 4, y equals to 0, x will draw the line. The first line we have 4 comma 0 and 0 comma 5. Last constraint is telling us we have to just the first quadrant. The first line will be from 5 to our first line. Second line is 5 comma 0 to 0 comma 3. The third line is 0 comma 4, 2 comma 0. Third line is now the conditions with equality are telling us that the first telling us look for the reason which is less than 20, black line. Under 20 means put 0 comma 0 here, 0 and 0 here, it's 0 and 0 is less than 20. That means that the reason for the first line is contains the origin. The first line is taking these points here. This reason is pushing towards the origin. Similarly, the second reason is also pushing. Third reason is also putting the reason to the origin side. So you have to take common reason. This is the common reason, also known as feasible reason. Feasibility means here we will check the optimal and we don't have to go. There is one special point here. This point is the intersection of red line and the just write the red equation x plus 5y equals 2 equation 2x plus y. Find this common intersection point. Divide by 5. 5y. That both x equals to 5 by 7. Y equals to 2 comma 7 4 10 y is 18 by 7. This point is 5 by 7. All the boundary points you have this and this. Now we have 3 points comma 0 5 by 7. We have the main in economics terms cost function z equals to 2x plus 3y, profit function x plus, put these all and check where it is happening to the max. 2 into 2, that is 4, that is 9. Is S7 plus 7 7 1. Clearly this is giving the maximum value is 64 by 7. Optimal. How you do problems? Just try to find the feasible reason diagram. Then you one problem. By solving this problem, the answer that the problem, and after that we will see what will happen if we have variables. Topics are left only variables case, the dual of the problem. This but in the next class solving this. If you have any doubt, meet in the next class.